This video is going to be about adding and subtracting polynomials. This is page 51 in your notebooks. So to begin with, on the last video, I kind of reminded y'all about like terms, how every single term is its own, how the x's are not the same as x squareds, are not the same as x cubes, are not the same as numbers or y's or z's. Each one is their own, and that we can combine like terms into a more simplified expression. So that's going to come into play now with what we're talking about with adding and subtracting polynomials. So with polynomials, now, to be honest, I don't know why this is up here. I'm pretty sure it's something Miss Johnny put on her notes, and if you really want to know, you can go ask her. I don't know, so we're just going to go with what I do know. So here we go. Like terms are defined as having the same base and the same exponent. We'll get more involved in what bases mean in a couple of pages when we're dealing with laws of exponents, but basically x squared, x cubed, y squared, y cubed. The x and the y, the variable itself, are your base. The exponent is the tiny number up at the top. Now, when you are adding and subtracting polynomials, you always add and subtract left to right. Just like we do in PEMDAS, we always go left to right. Like when we read in English, we go left to right. And all that good stuff. So first of all, let's start with the rules for adding and subtracting, which we're just going to write over here on the side. The first one, it's just like when we were combining like terms last semester and dealing with PEMDAS and solving for a variable, anything like that, we're always going to do the same steps. The first step is you want to distribute, which means to multiply, for those that didn't remember. I'm going to try to write to the side so you can see. You're not looking at my dumb hand while I'm writing, so you can see what I'm writing. Hopefully that works out. If not, I'm sorry. You want to distribute the number that is in front of the parentheses to everything inside the parentheses, to everything. Now, some of y'all, when we distribute, you'll distribute for the first one, you'll do this, but you won't do the second one, and that's where y'all mess up on tests, so cut that out. We want to distribute to everything inside the parentheses. All right. Then always our second step would be to combine like terms. And then third, when we're dealing with these polynomials, we want to make sure we write it in standard form as the final answer. So write in standard form as the final answer, which on page 50, if you need help remembering what standard form is, the definition and how we did that was on the last page, page 50. So let's talk about adding first. So we are going to add these two polynomials together. So step number one is to distribute. So we have this positive 2 on the outside that we need to distribute to both. Now, some of y'all like to do the box method, so if you prefer that, then you do you. If you don't want to do the box method, you're good doing that or doing it in your head. I don't care, as long as you get it done, you do it right. So 2 times 8m will be 16m. 2 times 5 is going to be 10. So if I just were to rewrite this expression, I would then be adding a 16m plus 10. Now, forgot that. Now the second thing would be to combine like terms. So do you remember last semester, where's my little sheet here? So last semester when we had, let me remember, so let's say we did y plus 2x minus 3 plus 5x minus 5y, something like that. Do you remember how we circled one term, boxed another term, triangled a third term, and then the x's were the box and the y's are the circles? If you want to go back to doing that for this, that's fine as well. So we would combine y and negative 5y to give, a minus 4y. 2x plus 5x would be 7x, and then there was no other triangles, so we just put that down the end. Since this was positive, it was a plus, and that would be our polynomial. That's kind of what we're doing here. We're just going to spruce it up a little bit without doing the circles and the squares and the triangles, and I'm going to show you two methods on how you can get this done. So the first method is just to rewrite everything. So the 12m squared a positive 4, a positive 16m, and a positive 10. So just like we did with the circles and the squares, here's an m squared, a number, a regular m, and a number. So we're just going to combine these two. These get whatever. So there's nothing to combine them with. So we're just going to rewrite them as they are. So we're going to say 12m squared plus 16m, and then 4 plus 10 will be 14. And then this would be your polynomial. Now the third step is to write it in standard form, but if you're conscious of that to begin with, it should be in standard form. So you see how I did the 2, the 1, and then the 0. So I already have that done. Now let me show you the second way, which is what I mostly do when I personally solve stuff. I kind of stack it on top of each other and make it like a normal addition problem. So here's the second way. So I'm going to take the polynomials that I have up here. So I'm going to say 12m squared, and then I'm going to skip a space and write plus 4. The reason why I'm skipping a space is I don't have any m's in this first term. So sometimes kids like to write a 0m in there to like leave that space. There are no m's, which is why we have 0, but we want to leave the space because there are m's up here in this second term. So then I'm going to add to it the second parentheses. I don't have any m squareds, but there are 16 m's, and then there are positive 10's. And then we just add them together. So since there are no m squareds, that's just going to give me 12m squareds. 0 plus 16 is positive 16m. 4 plus 10 is positive 14. Then it's the same that you got up there. So that's two different ways in which you can solve or simplify an addition problem. It's going to be the same on subtraction as well, and it really doesn't matter which way works. You know, they both work the same. You just do what works best for you. Okay, so that's when we're adding. Now let's look at subtraction. Subtraction is only slightly harder because it is subtraction, and you know, y'all mess up with the negatives like nobody's business. So hopefully after I explain it, you'll be able to be a little better at it. All right, so again, first step is to distribute the number outside. So what this is saying is you've got 2x cubed plus 4x squared minus 6 minus this whole thing. When they use parentheses, they're saying we're subtracting this whole trinomial, not just the 5x cubed. So there is an understood -1 there. So you can do the distribution. Okay, again, there are two methods. The first one would be this. Sorry, it's kind of shaking the video, my bad. I'm getting fidgety. So we're going to distribute a -1 to all three things. You cannot forget to distribute to everything in parentheses. So if you're the one that forgets to distribute to everything, then don't use this method. Use the second one I'm about to show you. So a negative times a positive will give me a -5x cubed. Negative times a positive is a -2x squared. Negative times a negative gives me a positive 2. All right, so then I bring down this other mess, 2x cubed plus 4x squared minus 6. So then we just kind of can stack them on each other like I did up here in this example, and we can add because we've already distributed that negative. So we can now add these two things together and we're good. We're basically just combining like terms. You've got a 2x cubed, a 4x squared, and a -6. And then we're combining a -5x cubed, a -2x squared, and a positive 2. This was positive, well, sorry. So we're just going to add them together. 2 minus 5 is -3x cubed. Ooh, that's an ugly 3, my bad. We got a positive 4 minus 2 gives me a positive 2x squared, and -6 plus 2 is a -4. So that would be the simplified polynomial. That's that subtraction. Okay, so that's the first way. Now the second way you might find a little easier with subtraction. I know I do. It helps me better than anything. So what I'm going to do is I'm just going to write my my first polynomial just like I did up here. Now if there are any gaps, I don't have x to the 1 power, but if I look over here, there are no x's to the first power either, so I don't need to leave that gap like I did up here. All right, so I'm just going to rewrite that. So 2x cubed plus 4x squared minus 6. Okay, now I'm not going to distribute this -1. I'm just going to rewrite what's in parentheses under these. So that 5x cubed goes here. there's a positive 2x squared, and then that's a minus 2. Now, because I am subtracting, I've got to subtract everything. So I'm just going to go and say minus, minus, minus. Then you treat them like they're like individual problems. So 2 minus 5 is again that negative 3x cubed. 4 minus 2 is a positive 2x squared. Negative 6 minus a negative 2. So remember, what happens when we minus a negative? We're actually adding. So this is actually adding. So negative 6 plus 2 gives me a negative 4. This is positive. So it's really ugly. So then we're going to come back, and then that will be our answer. So again, either of these two ways will work for you. Just pick one and go with it. This one is the one I prefer because it reminds me to negative, 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 and I don't forget to distribute a negative to everything in here. But, you know, whichever way works best for you. Okay? All right, so now I'm going to do the rectangle expression with y'all. So go ahead and read that to yourself, or actually I'm going to read it to you, so because I'm here by myself talking to myself, so I might as well read to myself. Good times. So it says, write an expression to describe the perimeter of the rectangle below. So what does perimeter mean? Hopefully you said and you remember that perimeter means to add up all sides. Add up all sides. Okay, that's perimeter. Area means to multiply. So today, because we're doing adding and subtracting polynomials, we're going to deal with perimeter because it's about adding. Now, this is a rectangle. So what do we remember about rectangles? Hopefully you said to yourself that you know that the opposite sides are congruent to each other. So this side equals this side is the same as this side. So basically it's like saying over here we've also got 6 plus 2a squared, and down here this is also 3a squared minus 4a plus 5. Now, there are two ways to solve this problem as well. I don't know which one will be easier for y'all, so I'm just going to I guess I'll just show you both, whichever. So just leave space. If you're one of those that writes huge, watch the video first, see which way you like best, and then copy that way down. That might be the easiest way. I don't know. Okay, so the first way I'm going to do is I'm just going to add up all sides. So I've got 3a squared minus 4a plus 5. Then I've got another one. 3a squared minus 4a plus 5. Then I've got to add these two sides as well. Now, this is written as 6 plus 2a squared. But I'm going to write them where they belong. So this is going to go 2a squared here plus 6, and I don't have an a, so I'm leaving that spot. Then I've got to do this side as well. All right, so again, I'm just going to write them where they belong. And I'm adding them all up together. Okay, so I've got 1, 2, 3, 4 sides. And then we combine like terms. So 3 plus 3 is 6, 7, 8, 9, 10. So this will be 10a squared. Now, if you're using your calculator, you can't put in the variables on your calculate screen, children. I've told you this more than once. You can only just add up the numbers in front. These are called the coefficients. So just do 3 plus 3 plus 2 plus 2, and you should get 10 as long as you did it right. Same thing here. You've got negative 4 plus negative 4. So two negative 4s make a negative 8a. And then you add up these numbers just like normal. 5 plus 5 plus 6 plus 6. So what's that in my head? This is 10, this is 12, so 10 plus 12 is what, 22? Something like that. So this should be the perimeter of this rectangle. Okay, so again, that's the first way. If you like that way, then you can write it down, but I suggest watching the second way. It's slightly more, it's not more difficult, but it takes more brain power. This, you just kind of write crap down and add it together. Second one, it takes a little bit more brain power. So here we go, second option. So I know that there are two sides that are 3a squared minus 4a plus 5. And then there are two sides that are 6 plus 2a squared. So I can say that there are 2 of this long side, 2 of this short side. So then we just distribute or do the box method. So 2 times 3 is 6a squared. 2 times negative 4 is negative 8a. 2 times 5 is a positive 10. Then you've got to distribute over here. So that's plus 12, and then plus 2 times 2 is 4a squared. So then we're back to just putting the stuff together. So I've got a 6a squared and a 4a squared. That gives me 10a squared. There are no other a's, so we write negative 8a, and then combine the 10 and the 12, which gives me plus 22. Okay, so that's the second way that you can get that done. All right, so either way is option. Now I will tell you, you do have a quiz on this next week, and there will be a problem like this on your quiz. So there's 2 more problems kind of like it on the back. I would suggest actually trying to do them on your own, and if not, getting help from one of the teachers that are in the room that know math. So there's that. Okay, so backside, you have your individual practice to do. I will do one of each kind with you, and then you'll have 4 to do on your own. Down here. That way you can practice, and if you're not getting it, you can ask for help. So I'm going to do the adding example and then the subtracting example, and then y'all will do the other ones on your own. So here we go, adding first. I like zooming in. This is kind of fun. Good stuff. All right, so you're adding this plus this. So to make it easier on myself, I just take these and stick them under the crap that's the same. Excuse me, stick them under the stuff that's the same. I know, Alex, I'm sorry. And then we're going to add. So I've got an x squared goes here, a plus 3 goes here. So I don't have any x's in this polynomial. So I'm just leaving that blank. And we're going to add. 3 plus 1 is 4x squared. There are no x's. So again, if you need to write that 0x there to remind yourself there aren't any x's, feel free, as long as it doesn't mess you up. Negative 5 plus 0 is negative 5x. And then negative 1 plus 3 will be positive 2. That will be that. Okay? And then I'll do the subtraction problem with you. There we go. So I'm going to line these up. Now this one, it's important that this one is the one that goes underneath because we're subtracting this one. We wouldn't want to do this minus this first one because that's not how it's written. It's this polynomial minus this polynomial. So I'm going to line them up. X squared under x squared, negative 3x under the x, and a positive 1 under the 3. And then I'm going to minus, minus, minus. So 2 minus 1 is 1, x squared. X minus a negative, so remember that's just plus. So 1 plus 3 is 4x. And negative 3 minus a positive 1, so that's just like saying negative 3 minus 1, which gives me minus 4. Okay, so you have the rest of the back page to do. And then I will have another link video with the answer key. And again, you can always ask whichever math teachers in the room to help you out if you're stuck. At least try to get one of these done and then the this one. If you can't get all 4 done, at least get the word problem and then one of these. Try your best, okay? All right, have fun.